Okay, guys, so in this video, we're going to finish off what we couldn't finish in class. Okay, so for both my class in the morning and my class in the afternoon, we finished here, right? So we didn't really talk about the degree of the equation. This part is really easy. So the degree of an equation or the degree of a function is the greatest here exponent used in the terms involved in the equation. So for example, if we're talking about, let's say, trinomials, a trinomial ax squared plus bx plus c, then obviously a trinomial has a degree of 2, right? But here we're talking about linear equation, which means the general form, just like we have a general form for trinomials, we have a general form for linear equation as well. It's mx plus b. So this is the general form of a linear function, okay? And sometimes we say the general form is ax plus b plus c is equal to 0. So these two forms, they're actually the same, okay? We use different letters, but they are the same form, okay? They represent the same relation. So we can see from these two equations or these two functions that the greatest exponent used in the equations is 1. 1. And that means linear equations all have degree of 1. Okay. So we know that all the linear equations have degree of 1. And that means if an equation has a degree of 1, then that means this equation is a linear equation or linear relation. Okay. And it says, not all the graphs of relations are straight lines. If the graph is not a straight line, it is non-linear relation. Remember what I said in class? I think I said that maybe multiple times. In mathematics, linear equation or linear relation and straight lines are mathematically equivalent. Okay, so there are just two different representations, but they are the same thing. Okay, so when you see linear relations, you know that this is mathematically equivalent to straight lines. Okay. Okay, so let's look at the class practice. The defining equations given for some relations may not have an obvious independent variable. One way to graph such an equation is to isolate y or x and make it the independent variable. Okay. Express the relation 2x minus 3y is equal to 6 in terms of y, which means we need to solve for y and represent the equation in terms of y, which means we need to change this equation to the form y is equal to something, solve for y, and make a table of values, graph the relation. Okay, so we know, so the question is asking us to express the relation in terms of y. So let's solve for y. Okay. So the equation here is 2x minus 3y is equal to 6. So we need to solve for y. Okay, we need to express this equation in terms of y. Okay. So if we move y to this side, it will be 3y plus 6 is equal to 2x. And this, if we move 6 to this side, it will be 3y is equal to 6 minus 6 plus 2y. And if we divide 3 on both sides of the equation, this will become y is equal to minus 2 plus 2 over 3. Oh, sorry, this should be x. This should be x. X. Okay. And so our answer is y is equal to minus 2 plus 2 over 3x. And answer here is y is equal to 2 over 3x minus 2. So our answer is right. Okay. And here we take different values of x and we find the corresponding value of y. And remember here, I think I also said this in class, every straight line can be determined by two separate points on the straight line, right? So technically we only need 2 points, right? As long as we have 2 points, we can define the straight line. So when x is equal to minus 3, when x is equal to minus 3, y is equal to 2 over 3 times minus 3 minus 2 minus 2 minus 2 is minus 4. So y is equal to minus 4. And this means 3 minus 4 is on our straight line, right? When x is equal to 0, y is equal to, so this part is 0, 0 minus 2, minus 2, minus 2, which means 0 minus 2 is also on the straight line. If we have these 2 points, we can already draw the straight line, okay? But let's do the other 2 points. When x is equal to 3, y is equal to 2 over 3 times 3 minus 2. So 3 canceled out, only 2 is left, right? 2 minus 2 is 0. So 3, 0. This is also on the straight line. When x is equal to 6, this is 2 over 3 times 6 minus 2. And 4, 2. So the answer is 2, which means 6, 2 is also on the straight line. Okay. So now we have 4 points here, right? As long as we use 2 of the 4 points, we can draw the straight line. So let's just use the first 2, okay? The first one is minus 3 minus 4. So we start from here. This is 0, 0. We go with x first. So minus 1, minus 2, minus 3, and then we go down. 1, 2, 3, 4. So this point is minus 3, minus 4. Okay, so let's call this A. Let's call this A, B, C, D. B, point B has coordinates of 0, minus 2. So again, we go from here. So this is here. We go from here. 0, x is 0. So it's on y-axis. And then we go down. Minus 1, minus 2. So B is here. This is B. And then we draw a straight line that passes through both points. Okay. This is y is equal to 2 over 3x minus 2. Okay. If we want to verify whether our straight line is correct, we can use the other 2 points and see if these 2 points are also on the straight line. If they are, that means our straight line is right. If they're not, then we probably need to check our calculation and see if and see if there's any mistake. Okay, so let's try. C30. This should also be on the straight line. Okay, let's check. So this is 0. Okay, x is 3, so 1, 2, 3. Y is 0, so it should be on the x-axis. So this is a point. See, this point is also on this straight line. So, right. Let's see D. Point D, 6, 2. So 1, 2, 3, 4, 5, 6, 1, 2. So this should be the point. The problem here, when we draw the straight line with our pen and our eyes, it's really hard to do 100% precise and accurate, right? So there might be some like minor inaccuracy, but it doesn't mean we made a mistake. Okay, so here 1, 2, 3, 4, 5, 6, 1, 2. It's close enough. It's close enough. Okay, so it means we probably didn't draw the straight line like 100% perfectly, but it doesn't mean the straight line itself is wrong. Okay. So I think question 2 is very similar to question 1. So I'll just leave this to you. Okay. And now let's talk about intercepts. This is the last thing we need to talk about in this class. Okay. So intercepts, let's read the definition together. So the value of x at the point where the line crosses the x-axis is the x-intercept. The value of y at the point where the line crosses the y-axis is the y-intercept. Okay, so this might be a little bit hard to understand. So let's draw a graph and then you understand right away. So let's say we have this a plane, right? And I'm just going to draw a random straight line. Let's say this is my straight line. Okay, y is equal to mx plus b. Okay, so y is equal to mx plus b. This is a general form of a linear relation, linear function. So it is also the general form of a straight line. Okay, let's read the definitions again. The value of x at the point where the line crosses the x-axis is the x-intercept. So this is a line, this is the straight line, right? It crosses x-axis here, right? This is the straight line, this is the x-axis. So this is called the x-intercept. We say x-int. Okay. The value of y at the point where the line crosses the y-axis is the y-intercept. So again, this is a straight line and this is y-intercept. They cross here. So this point is called the y-intercept. Okay, and we should note that for x-intercept, so this point, because this point, on this point, the straight line and the x-axis intersect. There's no height, there's no y value. So for x-intercept, y is equal to 0. When y is equal to 0. Okay. With the same logic, for y-intercept, because this is a point where the straight line and y-axis intersect. Okay. On this point, there's no horizontal value. There's no x value. So for y-intercept, x is equal to 0. So how do we find the x and y intercepts when we are given an equation? Easy. So let's use this equation as an example. Okay, so if we have 4x minus 3y plus 12 is equal to 0, if the question is asking us to find the x-intercept, then we simply let y be 0 and we solve for x. So if we're asked to solve the x-intercept, we let y be 0 and then solve for x. Okay, so let's do it. Okay, so if we let y be 0, then the equation becomes 4x minus 3y. Y is 0, right? Y is 0, so 3y is 0. 0 plus 2 is equal to 0. Okay. Oh, sorry, it's not 2, it's 12. 12. Okay, so plus 12. And now we solve for x. Okay, we move 12 here. So 4x is equal to minus 12. So x is equal to minus 3. So the x-intercept is minus 3. If we are, okay, I'll just write it here. Okay, if we're asked to solve the y-intercept, then we simply let x be 0 and solve for y. Okay, so 4x minus 3y plus 12 is equal to 0. Here, x is equal to 0. So 0 minus 3y plus 12 is equal to 0. So 3y is equal to 12. So y is equal to 4. So here, 4 is the y-intercept. Okay, let's try another question. Let's try this question. 2x minus 3y is equal to 6. Let me add another piece of paper here. Okay. So 2x minus 3y is equal to 6. Okay. If we're asked to find the x-intercept, then that means we let we let y be equal to 0. Okay, and that means 2x minus 0 is equal to 6, which means x is equal to 3. So this is the x-intercept. Okay, for y-intercept, we let x be 0. That means 0 minus 3y is equal to 6. That means y is equal to minus 2. So minus 2 is the y-intercept. Okay, remember here, x, y, they're just distance, right? If I ask you, give me the coordinates of the x-intercept, the points, then for x-intercept, the point should be 3. What's the y value? 0, because we know y is 0 here. So this is a point where the x-intercept occurs. And y-intercept, the point should be x minus 2. Okay, so we need to know the difference between these two things. Okay, so this is distance. Okay, this is the x, y intercepts in terms of distance. And these two are the coordinates of the points where x-intercept and y-intercept are. Okay, so this is everything we need to know in this class. If I have time, then I will make more videos about I'll solve some questions in the video to show you how to solve these questions properly. Okay, but this is everything for now.